Hey you, do you want some code?
Welcome back. Let's try something fun. What happens if we keep calling functions nested inside each other repeatedly? In the previous video, we saw that when we call the calculate function on the line 10, then line 11, and the line 13, the stack gets pushed on and then popped off, pushed on and then popped off. But what if we have nested functions that keep on growing the stack until it becomes larger and larger and larger, until we cannot continue anymore? Well, that's called a Stack Overflow. It's named after a very popular website for developers, Stack Overflow. And causing a Stack Overflow, it's actually quite easy. Let's take a look. All we need to do is create a function. Let's call it inception. And this function will simply call itself. I know it looks confusing, but what we are using here is called recursion. Recursion is when a function calls itself. There are cases when recursion can be useful, but that is beyond the scope of this course. I will cover it in my other courses on data structures and algorithms. Recursion is one of the most common ways to create a Stack Overflow, or to have a lot of nested functions that keep growing the stack. In this case, if I run inception, it will keep adding things onto the stack continuously. So, what do you think happens if I run this? Well, I get a maximum call stack size exceeded arrow. The arrow message provides a stack frame of each entry, showing the state of the stack. If any function produces an arrow, JavaScript will print this stack trace, which is a snapshot of the code execution at the stack frame. As you can see here, I'm calling inception repeatedly. In the past with Chrome, it wouldn't give you this arrow, and the browser would eventually crash. However, to prevent the browser from crashing, if it reaches a limit, it will display this arrow message saying, "Hey, you've just created a Stack Overflow." How cool is that? Alright, so that's one way to cause a problem with our call stack. There is one of two places where our JavaScript engine works. But what about the memory heap? Is there a way to do something similar with a memory heap? Let's find out in our next video.